Bismillahirrahmanirrahim. Dear students, so today we are continue to solve our past papers of Ministry of Education, Oman. So 2024, 2025. Previously, we are discussing the six multiple choice question of this paper. Today we are solving the question number 7. Without wasting our time, we have to move forward. The question here is question number 7 here is the figure opposite show a fully charged capacitor with initial charge of 8.4 into 10 power minus 5 coulomb. Okay. What is the charge on the capacitor after 3.5 seconds? This figure is given. Okay. So here we have a capacitor over here and its value is 7 microfarad and the value of resistance is 0.4 mega ohm. Okay. So the first thing is how to solve this type of questions. To solving this question, the first thing is you have to know about it, which thing is given in this multiple choice question. You see that we have initial charge is given and the initial charge is 8.4 into 10 power minus 5. So I just write down there initial charge Q naught is equal to 8.4
التوجه إلى بعد
into
الطاقات
10 power
الطالب عامل من الصف الخامس التوجه إلى بعد
minus
الطاقات
5. Okay. And he is talking about this that we have a time here is 3.5 seconds. So time here is 3.5 second. Okay. Second thing is time. Third thing is given, which is C value of C, which is 7 microfarad. So just write down there C is equal to 7 microfarad. And obviously it will be equal to 7 into 10 power minus 6 farad. Okay. And the value of resistance is also given, which is 0.4 mega ohm. So R is equal to 0.4 into 10 power mega. Mega mean plus 6 ohm. Okay. So this thing is given. And he is asking you to what is the charge? What is the value of charge? So value of charge here is Q. You have to find the value of charge here. Okay. So now how to solve this question? Whenever you look at the formula sheet of this topics, you see that we have one formula is given and that formula is Q is equal to Q naught e raised to power of minus T divided by RC. Okay. So this formula sheet is given. So just we have to put the value and you can find out the value of Q and all of y. Okay. So whenever you put the value, so Q is equal to Q naught. What is the value of Q naught? It will be 8.4 into 10 power minus 5. So this is the value of Q naught and we have exponential function. So e raised to the power of minus, what is the value of t? It will be 3.5. So just write down here 3.5 divided by what is the value of r? Here the value of r is 0.4 into 10 power plus 6. Okay. And the value of c here is 7. So 7 multiplied by 10 power minus 6. Okay. So when you solve this question, you will get the answer and the answer will be 2.4 into 10 power minus 5. Just put the value in the calculator. You can easily find out the value of this question. Okay. So this is my question number 7. Now we have to move question number 8. For question number 8, you see that okay, just first one, I just remove this thing so it will be easy for everyone to understand these questions. Okay. So question number here 8 it is. Okay. So question number here 8 is the region around a magnet where the force is exist. So he is talking about the region. At which region that we have the force exist. Okay. So we see that we have a magnet and then we have a north pole and we have a south pole, and around the magnet we have a region, and that region is called, that field is called magnetic field. So the answer here is magnetic field, not magnetic pole, not magnetic material, magnetic flux density. So the right answer is magnetic field because this is a field around the magnet. So that's why the right answer is magnetic field. So some student asked this, the magnetic flux density. Some student that is magnetic flux density is also B. So what is the difference between them? Or right? So remember one thing whenever you're talking about the magnetic flux density. So remember one thing. So we have this is a actual the generalized magnetic field, magnetic flux density. But here we are talking about the around the magnet. So this is actually the field, the space around the magnet where the test charge experience, test magnet is experience a force is called magnetic field. So the right answer here is magnetic field, not a magnetic flux density. Okay, magnetic flux density is, for example, if we have a wire like this and this is around the magnet, so we can say that this is a magnetic flux density. All right. So here the correct option here is option number B here. Okay, now we have to move question number 9. Oh yes, this question is come from the Hall effect, and we have to solve this question. And the question here is, okay, wait a minute. Yes. The question here is the figure opposite shows up the Hall effect of experiment. What is the number density of the charge carrier? He is talking about the number density of the charge carrier. We just simply put the formula and you can easily find out the number density of the charge carrier. So what is the formula of this? So whenever you look at the formula sheet, so we see that here, yes, Hall effect is given. So we can see that this formula is already given here. And the formula is VH is equal to BI divided by NTQ. From here, you can find the value of N. VH is equal to BI divided by NTQ. So put this value and you can find the answer. BI divided by NTQ. Okay, so this is the formula sheet. Okay, so the formula here is BI. Wait a minute. So V Hall effect is equal to BI divided by NTQ. Okay. Here we have to find the value of N. So you just rearrange this equation. So N is equal to BI divided by VHTQ. Okay, just put the value and you can get the answer here. Okay, so here B is 85 multiplied by 10 power minus 3. So just put here 85 into 10 power minus 3. Okay, and I here is 9 ampere. So just put the value 9 divided by VH. Here VH is 4 multiplied by 10 power minus 7. So 4 multiplied by 10 power minus 7. And obviously T is a thickness, not a time. Okay, so T here is 0.2 into 10 power minus 3. And here the Q, the value of Q is obviously constant. It will be 1.6 into 10 power minus 19. Okay, so whenever you solve this question, so you have to get the value 6 multiplied by 10 power 28 electron per meter cube. So this is your right answer. Just put the value in the calculator and you will get the answer of this question. Okay. Now we have to move the question number 10. Oh my God, this is a very tricky one. So we have to solve this question number 10. It's a very interesting question. Okay. So the first thing is whenever this type of question will come in your exam. So don't be confused and don't be afraid of this question. It will be tricky but easy one. Okay. Not a very much tough one. Okay. So the question here is the figure below shows a current carrying wire is placed in a uniform magnetic field. Current carrying wire mean we have I. Placed in a uniform magnetic field, so we have P. Experience a force, we have F. At position 1, so position 1 is obviously perpendicular. So it's mean that we have theta here is 90 degree. Okay. When the length is reduced to half, so remember one thing, initially the length is L. But here the length is reduced to half. So L divided by 2 and it rotate at a position 2. So we have new angle theta, the force will become 0.3. So it's mean that force F2 is also given, which is 0.3. See, F1 is 0.1.2 and F2 is 0.3. All right. So what is the angle? So we have to find the angles. So how to solve this question? Most of the student will confuse that there is no data over here and how to calculate this type of question. So for solving this question, whenever you look at the formula sheet, you have to find the formula which have current, magnetic field and length. And obviously there is only one formula over here, and the formula is F is equal to B I L sine of theta. So this is the formula that we will use to solve this question. Okay. So first of all, we have to solve the question for the force F1. Okay. So force F1 is equal to B. Obviously, B is constant. So just write down here B. I is also constant. So just write down there I. L is length L. So we just write down there L. And initially the angle is perpendicular. So just write down there sine of 90, and which is equal to sine 90 is 1, so which is equal to BIL. This is my equation number 1. Okay, now we have to move for the second force, which is equal to F2. Obviously, for making the value of F2, which is equal to F2, so B is constant, so just write down there B. Current is also constant, so just write down there I. But the length is reduced to half, so it's mean that length is L divided by 2. But we don't know the value of angle because we have to find the value of angle. So just write down there sine of theta. So this is my equation number 2. Okay. After finding this equation, you just divide equation 2 and equation 1. So just write down there F2 divided by F1 is equal to, here F2 is BIL by 2 sine of theta. All right. Divided by, so we have a division like this. So we have BIL. So divided by BF, the value of F1 is BIL. Okay. So obviously this thing is cancelled. IBL is cancelled out. So this thing is cancelled. Okay. So remaining term is F2 divided by F1 is equal to sine of theta divided by 2. Okay. Just put the value and you can get the answer. Okay. So F2 here is 0.3. So 0.3 and F1 is 1.2, which is equal to sine of theta divided by 2. So when you multiply this thing, so 2 multiplied by 0.3 divided by 1.2 is equal to sine of theta. So it will be equal to 0.6 divided by 1.2 sine of theta is equal to sine of theta. So it will be equal to 1 by 2. Okay, so sine theta 1 by 2, which will be theta, will be equal to 30 degrees. So your right answer here is 30 degree. Okay, so this is the method that you can solve this type of question. Okay, so we have to move the next question. Question number 11. Okay, yes, question number 11. Very, very interesting question. And we have to just a little bit decrease like this. Okay. Now we have to solve this question number 11. And the question number 11 is very interesting one. Okay, okay, okay. Move from here. Question number 11. Yes. Okay. Yes. Good, 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 good. I am want to learn Arabic, but it's a very difficult one. So that's why I don't know Arabic. Okay, 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 okay. Yes. Question number 11 here. Question number 11 here is a coil is placed uniform magnetic field, then the coil is rotated and the figure show which is the correct during this rotation. Okay. So first thing is you see that here we have the cross. So remember one thing, when we have a cross like this thing, it's mean that magnetic field is out of the page. So magnetic field B is out of the page. Okay. But if it has a dot like this, so it's mean that B into the page, B into page. So this is very important trick. So you have to know about it. Okay. So remember one thing, we have a coil like this, and obviously magnetic field is out of the page like this. So he said that when we rotate the coil like this, now we have a coil like this, but magnetic field is also out of the page. Okay. The first thing is, what about the magnetic flux through the coil? So the first thing is, whenever you see that when the coil is placed perpendicular to the magnetic field, obviously the magnetic field line is moved large. So large number of magnetic field line move. Here, when we rotate the coil, so small number of magnetic field line, obviously, so it's mean that the magnetic field is decreases. It's mean that the first answer is wrong, second answer is wrong. So we have two option, either decrease, this is decrease, this is decrease. Okay. So we have two options over here. So now what is the exact answer? Decrease and decrease. Now what about the EMF? So remember one thing. So when you rotate the coil, obviously the EMF is induced inside the coil. So the right answer here is induce. So C is your right answer. Decrease and induce. Okay. So this is the method that you can solve this type of question. Now we have to move further and solve the rest of the questions. Okay. 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 But just remove this thing. All right. Question number 12. Here is the graph opposite show a variation of magnetic flux through the coil versus the magnetic flux density passing perpendicular through it. What is the area of the coil? Obviously, so we have know the formula, that is phi is equal to BA. Okay. We have to find the area. So area is equal to phi divided by A. So what is the value of phi? Obviously, the value of phi, we take this point. Okay. So we have the value of phi 4 multiplied by 10 power minus 3. So 4 multiplied by 10 power minus 3. And we have, sorry, B. We have B, and the value of B is obviously 2 Tesla. So just write down there 2. So 2 ones are 2, 2 twos are 4. So your answer is 2 multiplied by 10 power minus 3, which is equal to 0.002 meter square. So this one is your right answer. This is a simple question, not a very much difficult one. Okay. So now we have to move question number 13 and look at this, what they are asking you. Question number 13. So question number 13, here it is. Okay, question number 13 here is, okay, in the figure, the letter represent the period. Okay, so they are talking about which letter represent the period. Okay, this is simple one question. Obviously, the A represent the amplitude. This is my amplitude. Okay, so remember one thing, for the taking the period, so we have to take from here to here. This is my whole period, starting from here to here. So obviously C is the representation of time period. And this is also the, we can say that this is also my one wavelength. Okay, so this you have the right answer like this. Okay, so this option number C is the representation of period. Okay, so question number 14 here is, very interesting one question. So the question here is, but before that, I just remove this thing. I don't want this dusty things. Just clean it out. Okay. Which diode will conduct with terminal X of the input is positive with representation of the Y? Okay. So which diode is used for this? Okay. So we have 4 diode over here. So first of all, take this thing, X is positive and Y is negative. Before solving this question, you have to understand the one thing. Okay. For example, if we have a diode like this is my diode. So remember one thing, in this diode, this arrow is actually my P side and this line is actually my N. Okay. So remember one thing, when P is connected with positive terminal and N is connected with negative terminal, so we call it forward bias. So forward bias. And in forward bias, current is flow. But in reverse bias, so we have this diode like this, and this is my P and this is my N. When P is connected with negative and N is connected with positive, so this is my reverse bias. Reverse bias. Okay, now we have to solve this question. So we have to take any terminal. X is positive, Y is negative, so they are moving from here. Positive, moving. This time is not. Okay, so we have two diodes, 1 and 3. So obviously some of the current will move towards the 3, some of the current will move towards the 1. So whenever they move towards the 3, so remember one thing, when P is when positive is connected with N. Look at this. This is my line. This line is obviously N. Okay. So when positive is connected with N, so obviously no current is flow from here. So it's mean that no current is flow from here. So all the current will move from this point. Okay. So the first one is 1. Okay. So when they are moving towards this node, so some current is moving from second diode and some current is moving in downward direction. Obviously, when they are moving in the second diode, so we have also the same terminal. So this is my line here. So line is obviously N type and is connected with positive. So no current is flow like this. Okay. So now there all the current is moving like this, moving towards the resistor, moving, and now this point. Now they are moving towards this point. Now remember one thing, some of the current will move from this point at point 3 and some current will move from at point 4. If the current is moving through point 3, so obviously they are moving like this and they are again moving like this. So it's mean that, and the some current is moving from 4, diode 4. Okay, so they are moving towards the diode 4 and they are moving this point. Okay, obviously they are moving like this, but they are moving, the output voltage here is this one. Okay, so the two diode is common, which is 1 and 4. So your answer here is 1 and 4. Okay, so this is the method that you can find out this question. Okay, so this is your multiple choice question. Now we have to move the part B and solve the questions of part B. Okay, okay, just remove this thing. So we have to solve part B. Okay, yes, question number, yes. Okay. The question number 1 here is question number 15. Write the two ways of connecting resistance in electric circuits. Okay, so we know that we have two ways over there to connect the resistance. Which one is the series combination, and the second one is parallel combination. So this is my right answer. So series combination and parallel combination. Okay, the second one is the 4 marks question. The first thing is we have to try and define the terms, definition, and unit. The rate of flow of charge. Rate of flow of charge means charge per unit time. So obviously we know that charge per unit time is always current. So just write down their current. And the unit of current is obviously ampere. So just write down this AMPHERE or A, just okay, no problem. And the second one is definition of resistance. So what is the definition of resistance? The opposition offered by a body, the opposition offered by a body to flow of electric charges or current. So resistance is actually to resist the charge or resist the current. And obviously its unit is ampere, ohm, represented by this thing like this. Okay. So this is the method that you have to find the value of resistance over here. Okay. Now we have to move the question number 16 over here. But before that, we have to solve this question. Remember one thing, whenever you solve this, so you have to get the marks. If you are not solving this, you are not getting the marks. So you have to memorize the definitions over here. And some important, exam is not difficult one, just a little bit tricky one. So if you have think about this question, you can easily solve these questions. Okay. Now move to the question number 16, obviously. Okay. The table below the properties of metallic wire. Okay, find the Rx and Ry. Okay, so we know the formula here. So first of all, we take the resistance of Rx. So Rx is equal to rho L divided by A. And we have the resistance of Ry. So Ry is equal to rho is rho by 4, rho divided by 4. Length is 2 times L, so 2 times L, and area is constant. So just write down the 2, 1, the 2, 2 to the 4. So which will be equal to Ry rho L divided by 2 times A. Now we have to take the ratio. So Rx over Ry is equal to Rx is rho L divided by A, and Ry here is obviously, so we will just take the inverse. So Ry here is rho L divided by 2 times A. So area cancel, rho L cancel. So Rx by Ry is equal to 2. Okay. So this is my answer. Question number 16's answer. Now we have to move the question number 17. Question number 16, part 2. And the question here is, when both wire are connected in series when both in the electric circuit, the number of electron decreases. Why? Okay. So he said that if we have one wire and we have the other wire, and now they are connected in series, so the number of electron is decreases. Number of electron is, current is decreases. Why? So obviously we know that when these two wire is connected in series, so resistance is increased. So in series, resistance increases, so current decreases. Okay. So we have to solve this question number 16, and the next phase, inshallah, we have to solve the question number 17 over here. Okay. If you have any question, you can discuss with me. All right. Thank you very much, and assalamu alaikum.